Solubility curves. Solutes normally dissolve in a particular solvent up to a limit. The maximum mass of solute which dissolves in 100 grams of a given solvent is called the solubility of the solute in that solvent. Right? So since solubility depends on the temperature, one should always state the temperature at which the solubility is measured. So we looked at the other example and we said 91 grams per 100 milliliters. Right? So we know that's the solubility, but we have to say at 25 degrees Celsius because this amount can change. This amount changes based on whatever the temperature is. So if the temperature increases, this amount that can dissolve, the solubility, increases as well. We lower that temperature, the amount of solute that can dissolve, so the solubility lowers. Substances vary widely in their solubility behavior as shown here in the following solubility curve. Solubility curves can be used to identify unknown substances as solubility is a characteristic property. Right? So solubility is an actual characteristic property. So we look at these temperatures here. Right? Notice the curve with certain types of ionic substances. Right? So the amount of solubility that actually increases depending on whatever given temperature that we have. So let's look at a problem where we can actually use this solubility curve here. So in this first sample problem, if potassium chloride solution is cooled from 80 degrees Celsius to 50 degrees Celsius, what mass will precipitate out of solution? So we look at the potassium chlorate, which is this one in this light blue. So we look at the 80 degrees Celsius mark. Okay. So here's 80 degrees. And we look at 50 degrees. So here's this point. Here is our other point. So at 80 degrees, at 80 degrees Celsius, 35 grams will dissolve in 100 grams of water. Okay, we're using grams of water according to this chart. We've looked at milliliters. If you want, you can treat it as milliliters. Now, at 50 degrees Celsius, 18 grams of potassium chlorate will dissolve in 100 grams of water. So, now, what mass will actually precipitate out? So we're going from a higher temperature to a lower temperature. Because we're doing that, we know that it's going to be supersaturated. It's going to be supersaturated until it precipitates itself out. So what do? Well, we take the two values and we subtract them. 35 grams minus 18 grams based on the numbers we found here on the solubility curve. And we subtract the two together to get 17 grams of potassium chlorate, okay, will precipitate from this solution. So we just take the two values and we subtract them to one another. So that's a nice simple sample problem. Let's look at another one where we actually involve an extra step. A saturated solution of potassium nitrate is cooled from 50 degrees Celsius to 100 degrees Celsius. How many grams of this salt will precipitate out of 240 grams of water? So we have potassium nitrate. So here it is, the yellow curve. So we look for the 50 degrees Celsius, and we look at the 10 degrees Celsius here. And we take the two values, okay, and at 50 degrees Celsius, we are able to dissolve 80 grams in 100 grams of water. At 10 degrees Celsius, obviously, here in this example, temperature, we're lowering the temperature, so we'll be able to dissolve a lot less. We can only dissolve 19 grams per 100 grams of water. So 80 grams of potassium nitrate in 100 grams of water. We lower the temperature, and we can only dissolve 19 grams per 100 grams of water. So we subtract the two. Okay, so 80 grams minus 19 grams. And we know that we are able to dissolve, or 61 grams will actually precipitate out from this solution, which means only a lot less will actually be dissolved within the solution. But now, we know it's a ratio. 61 grams per 100 grams will actually precipitate out. But now, we don't have 100 grams. We have 240 grams of water. So we want to find out how many grams per 240. But we know that if we went from 100 grams to 200 grams, we would just multiply this by 2. We multiply this by 2, which means we multiply that by 2. But we're trying to find the ratio, and it's not as cut and dry as multiplying by 2 to get to 240. So we have to figure it out. So we use this ratio. Right? You think about regular ratio in math class. So we isolate for x. We keep x alone, which means I'm going to bring this 240 over. And so I get 61 grams times 240 grams divided by 100 grams, right? Grams of the water divide out, and I'm left with whatever grams of solute is remaining. And the mass of the potassium nitrate that is going to precipitate in a 240 gram amount of solvent of water that we're going to have, we're going to precipitate out 146.4 grams of potassium nitrate will actually precipitate out if we had 240 grams of water that we're dissolving it in. Dissociation, process of decomposing an ionic solid into its component ions. So NaCl can be broken down into its Na and its Cl negatives, right? Into the ionic solids that we can, right? So aqueous means that ions are hydrated. The ion is surrounded by water molecules, as we've talked about earlier on, right? If you think about one of the diagrams where I showed you guys, right? So the oxygen part is going to surround. The oxygen part is going to surround the Na. The hydrogen part of water is going to surround the Cl, right? So this is what we call hydrating it. The water molecules are electrostatically attracted to the ions, and it's called the solvation of ions, right? So here's another example, right? We've got the ammonium chloride. Right? So when we dissociate it, we are separating it into its positive ions and its negative ions, which are considered aqueous. Why are they aqueous? Because, again, it's surrounded by molecules of water. And what's going to surround here this ammonium? Again, the slightly negative oxygen of water molecules are going to surround this ammonium